Before we get started, let's just watch a video for a second.
Hundreds of thousands of people are going to die. You know what I want to do? I want to come way under the models. The professionals did the models. I was never involved in a model, but at least this kind of a model. But you know what? Hundreds of thousands of people, they say, I want much less than that. I want none, but it's too late for that. But I want very few people relative to what the models are saying. Those are projections. I hope they're wrong. I hope we're going to be under those projections.
Two questions on content.
So do models actually lie, or are they true? So we're actually going to use lots of methodologies in time series data, try to predict the future patterns in the time series data. And that all depends on the data source, depends on the behavior of the data, but we cannot trust the models 100%, which means that, of course, we try to do our best to predict the model. Doesn't mean that the model is wrong, it just means that it's going to be the best model applicable for that data set. So we talked about the components of time series data. First, we have the trend component, shows the increasing, decreasing, or the constant pattern in the time series data. Then we have the seasonal pattern in the time series data that usually happens over the actual seasons or based on the quarters of the data. We can have specific pattern that emerges or disappears. Third, we have the cyclical component in the time series data, which is another important concept that we need to watch out for in the time series data. We hopefully can model that. And finally, we have the random pattern that is going to always exist. It's going to be related to the error term, but it is very important to hopefully minimize the random component to the meaningful portion of the data. So we have lots of visualization available for us in Python, and including the visualization we use in pandas. So we have to pay attention to what we have available and when do we need to use specific types of visualization. In pandas, we have specific types of visualization on data frame that we can use, and we can use actually the matplotlib library from Python without using pandas library. But there is a very important concept in time series data we just need to be very careful about. So the main variable in time series data is the time data set, or the time variable. So we use datetime index to actually capture that variable. It is very important to make sure when you import your data set in the when you import your time series data set in Python, your time component or time variable is actually captured correctly. So Python does not always understand that correctly, so we may need to do some adjustments. We need to make some notes about the actual format we're using. So it is very critical to use that type of conversion process. So in Python, if we just use the Python, any datetime function would work, but we just need to make sure that we identify what is the format for that type of date variable. So for example, if we have the yearly data, we just need to identify that is going to be yearly data. If we have monthly, daily, hourly, even minute or second type of data, we just need to identify that, and we use the formatting to make sure we are correctly importing the data. Another datetime index that is available for us, which is the second type of date format, is the datetime in pandas. So we are going to identify that from the NumPy array. We identify datetime index, and then we identify what is the specific format of that datetime, which in this case we have daily data, so we just identify D as the daily data. There's a full reference for that, so if you go back to the second presentation, you can actually find that specific documentation. So to kind of review, recap, we have two different types of datetime, very similar, but gives us different options when we are going to customize or import time series data. First was the datetime index from the pandas library, and the second one is datetime from NumPy or pandas library. There are some other concepts that are reviewed in the second presentation for time series. First is time resampling. So time resampling is very similar to group by operation, which we are used to. And then we are going to aggregate the data based on specific criteria. So for example, in time series data, we want to aggregate the data based on days or month or years to get the idea about the average sales over a month or quarters or average annual sales. So that type of analysis requires new types of modeling, and that will be time resampling. But when we do the time resampling, remember the first several records, because there is no past record for them, you may get some not a number values after you finish your time resampling. So be careful about that. For example, if you have daily data and you get the monthly time resampling for that data, for that variable, the first 29 or 28 days, there is no previous month, so you cannot get the actual monthly mean for those records. So you are going to have, when you run the code, you're going to get not a number value. So we are going to see that when we are implementing the code later on, but just be careful about the time resampling output. So there are lots of options in time resampling, and you need to identify those. Of course, these are the default options: the ruling, the access. Make sure the ruling, you have the documentation so you know how you actually implement that. I'll show you an example in a bit. And also make sure you are pay attention to the access. Default is of course based on the actual columns, but you can actually change it later on. So these are the rule parameters. So for example, we are going to use a lot of daily operations if you have different values over the days, or if you have the monthly values or quarterly values or even yearly values, we may use the same type of different types of parameter rules. For example, if you use rule as equals as a, that means that you are getting that specific function over the year. So for example, if you're using mean, that will be the average over a year. Or if you're using the sum, that will be the aggregation or the summation over a specific year. The second important concept we need to take a look at is time shifting. So for time shifting, many times you need to calculate the shifted data. You need to shift your data down so you can actually align some of your parameters. So when you do that, if you do the shifting, you are going to get some missing values at the beginning or end of your data frame. So if you shift from the beginning, of course, the first record, that date, there is no value for the cosine or the volume. Or if you're shifting from the end or at the tail of the data frame, you're going to get some missing values at the end. So this example shows if you want to get the shifts over the month, and if you want to just shift values, every single value 1 month, you can actually do that. And then you can do it over a specific frequency that you define. So in this case, because we want to do that by month, we are going to use the rule as M, and then you can actually do different types of rules here, but it just all depends on what you're doing. We are going to get to the bottom of that later on to see what actually means when you are shifting the data. Another very important concept is known as rolling, and the second one is going to be expanding. But rolling is the first type of modeling we are going to implement on time series data. So what is the meaning of rolling? You can divide your data into specific windows. So imagine you have daily data, but instead of looking at every day's value, you can aggregate those values over a week or over a month. So if you have 10 years of data, you can aggregate them based on month, and every month you just calculate the average of those values. So you get a little bit more actually you get a little bit less detailed data, but it helps you to be able to build a model they can follow, and then hopefully you can predict, make some predictions. So for example, if you look at these values, the stock price closing values over different times in the year, you can make some rolling for those observations. So these are actual values, right? So you can actually aggregate those based on, for example, weeks, or based on days, or the ending time in the day if you have hourly values, and then that will be the representation you use. So if you have 20 hours, or let's say 12 hours worth of data over a year, over a day, you aggregate them and just use one at the end of the day. Just use that one value instead of using all of the values. So that will be a little bit more smooth function. That kind of orangish line is going to be your smooth function that you use, and that will be based on the window defined here. So that window could be 7, could be 30, could be 365. But don't forget, you just need to be aware of what is your data set. If your data is daily, of course that window 30 means monthly value. So the aggregated, or the average of monthly values at the end of the month, you just calculate those. If your window is 7, for this case we have the window 7, the rolling window is equal to 7, and what happens is that the first 6 rows or records, there is not going to be any value, because there is no 7-day worth of data we can calculate the average for. So we're gonna get some missing values here, or not a number of values here. But right there, when you start at the 7th day, now we can actually calculate the averages from the past 7 days. So we get some values here. The same process, you just need to apply it for specific variable. What we can do here is that we can calculate the window 30, which is the monthly for the daily data that we have, and we just call it something else. So we actually keep that in our data frame instead of having that somewhere else. We just add it as a new column. So we create that new column and just do the calculation for rolling and just apply it. And now we can actually plot it along with the original data. So this is the original data. Remember, we're gonna have some missing values. That's why this one the orange one starts later than, so it basically 30 days or 29 days after the blue line it starts. But then after that, that orange line is going to be following the average of the past 30 days. So every value would be the average of the past 30 days. So that's why it's kind of a smooth line that shows the behavior of our time series data, but of course is not 100% accurate. You see loss of difference at some points. It does not show you or capture you the local maxima or local minima. So these are the points that are missing. Another operation that we are doing in time series data is known as expanding. And the expanding option, it does look at all of the prior data rather than just a specific window. So when you expand the data, it just captures all of the previous data before that point and not the specific window. So it's not going to give you that 7-day or 30-day window. It just gives you the previous 7 days or 30 days or whatever is the point here worth of data. So over time, that expanding function kind of flats out, and you're gonna see a flatted value because the average of all these values is gonna get to the maximal that you get here. So this is just a review of the session 2 on time series data, and now we're gonna get to the session 3 of time series data, and we're going to talk about several topics. So just take a break, go back and maybe review the material one more time, and then we're going to come back to the objectives of the session 3 on time series data. Everyone now realize the value in data analytics. So one of the main types of advanced data is time series data. And let me talk about time series data briefly, and then we can talk about some of the examples that are critical for time series data. And there are some, of course, examples of how we can implement time series applications in Python. That's going to be our main concept and goal in this, the rest of this course. So let me go ahead and talk about the time series data. Basically, any data that has a connection to a time component can be seen as a time series data. It is going to be quantitative data because you need to have some numerical values connected to time. If you have qualitative values, if you have categorical values, you cannot use time series methods to analyze those information. For example, if you have a name of the customer every day that is connected to that date or the time that they made the purchase, you cannot just do the time series analysis for the name of the customer. So, right, you need to be careful about what type of analysis you can do with time series. For example, if you just think about the sales over the year or over the month or the days or over the hours, you can have time component variable, which is going to be your sales data. And then based on that, you can see the trends, you can see how those are going to be different across different times in the year or in the month or in the quarter. And our goal in the time series analysis is to predict something in the future. So if you know that there is a pattern in the past, you can actually trust the pattern, and then your model would adapt to that pattern. And then for the future observation, you can predict those values. So for example, in the time series component, in the time series analysis, you need to think about 4 components. The first component would be the trend component. And I'll talk about every single of these components in a bit, but you need to be sure about the differences across these 4 components, because some of the methods that we're going to use, they might not be able to analyze all of these components. Very critical to know the differences, because if you wanted to know the cyclical component and your method is not able to capture that, your analysis is basically useless. And the second component is seasonal component, the third is cyclical, and finally the random component. So every one of these components may be in your time series data. You may have 1 or 2 of these components in one of the data sets, or you may have all of those 4 components. So not every single time series component, and not every single time series data would have all these 4 components. All right. So let's talk about the trend component. You already have seen lots of analysis in regression, and you try to build the most fitted line and then try to understand what is happening across your observation. And finally, based on the regression model, you predict something in the future. And that's what we actually do in time series analysis as well. So we try to fit a line that is going to be following all of those points that we have made observation about. And for a new observation, we can just follow the slope of the line and the parameters of the line and find out what will be the value for that specific point. For example, for this figure, we can see lots of variations across different points in time, but our trend line would show an increasing trends or upward trend. So basically, if you have a new observation, depending on where it is actually located, if the point is located here, your trend, of course, could go up from this point, but the actual observation would be much less. So there is a difference between the trend value and the actual observation. And we try to hopefully find a line that could follow the exact line for these observations, which is not going to happen for the simple model. But for the little bit more complicated models, we can create a model that have a very close behavior to the actual observations. And the data for the trend analysis is usually taken different times of the year or period of the years. And these are going to be the values we observe, and then based on the rate of change, overall rate of change, we can say what is going to be the trend is going to be upward or downward, or it's going to be constant. The second component in time series data is a cyclical component. So any upward or downward swing that is repeated is going to be known as a cyclical component. And the cycles are usually the difference between the two closest up or down values. So if these are the two closest local maximum values, that is going to be our cycle. So the next cycle would be between these two values. Right? So maybe there is a cycle that's closer at the beginning of your data and then it kind of expands toward the end of your analysis, or it could be the other way around. So your cycle could be much more wide at the beginning of your data observation, but becomes much more close toward the end of your data observation. The third and very important component in time series data is the seasonal component. So many of the patterns that we see are related to our actual seasons. For example, the sales or the travel values would be related to the seasons, and that would be something really interesting. And they usually occur during the season. So if there's an increase in terms of the sales over the Christmas time, next year you come back, that is going to be still a high value. So that will be something we really wanted to take a look at, see if there is a seasonal component in our analysis or in our data set. Finally, the fourth or the last component in time series data is the random irregular component. So any of the data you may have, there should be, or there might be a trend, or definitely there is going to be a trend component. There is going to be possibly a seasonal and cyclical component. And then finally, because your model is not able to capture every single change in your data behavior, you may have that random component as well. So basically what we use to explain the random variation is by referring that to as a residual or error term. So those type of errors, of course, if we are lucky, we can have very small error term or residual values, but usually that's not going to happen. You may need to have much more data sets, observations. You may need to have much more rounds of analysis to be able to minimize that residual fluctuations. So I'm going to skip through those notebooks. By the way, this is going to be available, or it is already available on Blackboard. So if you don't have it, you can just go back to that weekly module and just download the presentation. So there are lots of things we can do with time series data, but before we do that, I wanted to suggest you guys to go back to your notebooks and review the NumPy and Pandas presentations. So that is what we actually have provided here. And I would suggest you guys just go back and review that on your own term. Maybe you already have that figured out because we already have done some analysis using NumPy and Pandas libraries. But if you forgot some of these, I would definitely suggest you guys go back and review the material, because it is really important for time series analysis that you understand how you can slice the data, how you can play with the data, how you can change the indices. So we can do the visualization with pandas as well, but in time series, that is going to be a very important step. It allows us to represent the behavior of the data, and that will be usually captured from the matplotlib library. Lots of visualization functions are going to be accessible through the matplotlib library, but our goal is not to visualize. Our goal is to really understand the data, create the forecasting model, and hopefully we can predict something for the future or new observation. We can do lots of visualizations, and this is just the review of that, but there is probably all the different libraries you can use for visualization, and you can definitely customize the way that you want, which is not going to be our goal here. But how do we really create these type of plots is based on that matplotlib library. So these are some of those functions that you can call and create the specific visualization chart, but make sure you understand how this works. For example, for histogram, you need to have some categorical values and then just show the distribution across those categories. But for line chart, you need to have some numerical values that have different ranges across different points, which could be the time series data. We usually show the changes across different times using time series data because the value is aligned to the point in time. So these are some examples for the histograms, and then these are examples that are available on the specific notebook, but I forgot to tell you, you can get these data files. If we go to data files folder on Blackboard, there are 3 data files, and these are the 3 data frames that we're going to use for this specific visualization. So if you want them, go there and download the CSV, put it into your Python folder, and then you can just come back and work on that notebook. Okay. So first thing, we want to create that bar chart, kind of shows us the distribution of these values and the frequency of each category. So this shows us the random distribution, very close to a bell-shaped diagram for that data frame 1. And of course, you can play with the coloring, with the edge coloring, and kind of playing with the figure size, scaling. So these are the functions you can easily find on your own, and based on the way you want to customize, you can clearly play with those customization. So just put some examples for your reference, but that's not going to be our main focus here. You can add the grid if you want, right? Kind of a specific grid line. You can set the labels to specific value. For the y-axis, we just set that to frequency. If you want to change that x-axis label, you have to assign that plot to a specific variable, and then for that variable, you call the label. And then you can create the bar chart for the values of these categories. For example, for DF2, you have 4 categories, A, B, C, D, and then for each of the values, you can show the distribution of those. Or you can have the stacked bar chart, which shows from the whole distribution of that specific value, how many of those are going to be the red category D here, how many are C, how many B, and how many A. This is very important because of the way we visualize values in time series, and you're going to see that a lot. We mostly focus on line type of plot because when you have your x-axis set to time, you can show how the value of your interest could change over time. So for example, if y-axis is your sales and x-axis is your yearly sales or annual sales, you can say how much
you sold over the past year. For example, if it's the aggregated annual sale, or if it's the average sale, you can have that value over different years, and every change in that value shows you specific behavior. For example, here we have a drop. What happened? Was it a recession? Was it a store closure? Was it a something else? Customer behavior has drastically changed. So what was the reason that we have seen that drastic decline in our Y value? And of course, you can set the settings for that. If you have different categories, you want to kind of show them side by side. Well, you can easily just call the column names and just show them along each other. And finally, you can use a scatter plot to show the distribution, to show the relationship between two values. So the variable A and variable B are going to be our variable of interest. And if you wanted to know how they are related, of course, you can create a regression model and see what is the relationship and look at their correlations, or you can just plot the scatter plot and see if you can identify a specific pattern here. And then in this case, of course, we see there's a little bit of random distribution. There's no clear relationship between the X or the A and B. It seems that, okay, so when we increase A, we have some very low values for B, and then same A value, we have a very high value for B. So it's not a very clear pattern or relationship. But of course, you can have a trend line, which is going to be the speed line for these observations. And I like this type of graph very much because it kind of shows us how we can emphasize on a combination of variables. So we can show the relationship between these two variables as a scatter plot between A and B, and then for the D value, we can identify a color ramp to show the strength of that third variable. So for example, if the third variable is the number of, I don't know, specific variable, which could be like the sales, or could be the number of hospital visits, that could be something you want to take a look at that in combination of the other two variables. And of course, there are different ways you can visualize it, but the concept is based on the third value strength.